Party's not over, folks. You thought it was, but we just that was like having a good night of drinking and then stopping for a little bit in the middle and drinking some water to make sure you don't get like fucking too hungover the next day. Hopefully y'all don't know what I'm talking about, but I'm sure some of you do. Math 35, since this is the second video. This is lecture day 11. Part B, we're doing 10.4, equations that are in quadratic form. Okay, so what this section is not on, this is not on solving quadratics. We know how to do that already. To solve quadratics, we can factor. We know how to do that. We can complete the square. We can extract roots. Sometimes that's the quick way to go. Or we can do the quadratic formula, which isn't always friendly, but it does take us directly to the answer. It's a one fucking trick pony, directly there. So, what are equations in quadratic form? Equations in quadratic form don't have x squared. Ax squared plus bx plus c equals 0, but with the right substitution, let's just spell that again. Substitution. It can look like, and I'll switch to U now. U is a common one that we like to do. What we're looking for, notice we have two terms with a U in it. And one exponent is double the other. That's what we're looking for. I think that's a shorter way of saying what I said in 335. No yawning, it's only 4. It's almost 4:20. Who cares? You know, that's like an event at Santa Cruz, like every day. And April 20th is a fucking giant day where students just gather and
Celebrate their birthday.
and celebrate the day.
So everything wanted over there.
Santa Cruz has got a lot of partying going on. Unless you're in the grad school and then no one's doing, like, maybe on the weekends, but not really. They're too busy. All right, so what the hell is he talking about? X to the 4th minus 9x squared plus 20 equals 0. So 4 is double 2. So what we're going to do is we're going to set u equal to the small variable. U equal to the variable with the smaller exponent. So we're gonna say u equals x squared. So x to the fourth is really x squared squared. And x squared is u, which means x to the fourth is u squared. So I will rewrite this as u squared minus 9u plus 20 equals 0. Now, it's worth remembering, we didn't start with u. We don't end with u. Or a nice, easy way to remember, this isn't about you. It's about me. That's some cheese right there, right? See how I did that? That's great stuff. It's not about you. All right, so we can do quadratic formula if we want. If you want to do it, go ahead and take a minute and figure out what u is, what the two solutions for u are. I'll wait. You can factor, you can complete the square if you're a psycho. You can use quadratic formula. I'm going to factor u minus 5 and u minus 4 equals 0. Once you get to this point, you can substitute in if you want, or you can solve for use. U equals 5, or U equals 4. But we didn't start with you. We didn't end with you. It ain't about you. It's about x squared. Now, this is clearly an extract roots thing. X equals plus or minus square root of 5. Or x equals plus or minus 2. How many total answers? There's 4, right? I got positive square root of 5, negative square root of 5. Positive 2, negative 2, 4 answers. Exponent was 4.
I have a question.
Yeah,
When is it that you throw in the plus minus?
you take the square root with an or an even root.
Even?
Like if you took the 4th root,
Oh, so x squared because we're doing the square root of x squared, then you throw the.
yeah, this is like doing, it's really the absolute value of x.
But if you were doing like x cubed,
That doesn't apply.
you wouldn't put plus minus?
No. Because if we take like the cube root of negative 8, the only answer is negative 2. The only answer of the cube root of positive 8 is positive 2. I can't use the negative there because the odd exponent keeps the sign. Whereas the negative, when you have an even exponent, doesn't matter if you start with positive or negative, when you square it, it becomes positive.
That could be.
Any even exponent.
Any exponent past 3. Or it's multiple, any exponent that's multiple.
Yeah, 6 could be treated as a cube root. But I would treat it as an even. Well, it depends. We'll talk more about this later, this coincidence, which is not coincidence. There is at most, with the exponent is n, there's at most n different solutions. Sometimes a solution gets repeated. Like when we had the discriminant equals 0. It's actually called a double root, but that's another day, another dollar, not today. So even though there's only one root, that's why we say at most n roots. Just bringing your attention to it now, so like it doesn't look out of place later on when we do it again. Do you need this up longer, sir? Or you're just taking it? Okay. All right, so what about something like any ideas?
This is a quadratic to 1/2.
That is 7x to the 1/2. And that is x to the first.
It's the same thing, but
So the smaller one is half the bigger one. So we're gonna say u equals x to the 1/2. Before I do, I know some people like lists of shit we're gonna do, so step 1. Find the u sub is what we call it. The u substitution. And do it. We use u commonly because a lot. Whenever we're doing a substitution, u is a good choice. Unless the letter you were starting with is u. That way, if you get in the habit of it, you'll go, oh yeah, it ain't about you. You get rid of u at the end. It's easier to remember. To solve the resulting equation like we did. Three. Backsa or replace U with its equivalent. So that you can solve for the original variable. And you should check your solutions. I didn't do this on the last one, I should have. Maybe we'll go back and check the solutions on the last one after we finish this problem. It's so interesting. This is probably stupid, but. Most people hair just parts, it's like half goes down one side, half goes down the other. Everyone, like, unless your hair is like all over the place. Everybody's hair in here is parted like that, except Megan's. Hers makes a fucking triangle where bangs going forward, and she doesn't have a part. It just fucking perfectly flows outward around her head radially. And there's no part line, that's fucking bizarre. I only notice that because you're looking down a lot, so I see the top of your head a lot. It's fucking weird, right? It's a little triangle, you got like a little triangle right here. And now you're gonna take a picture of the top of your head, you look at it and go, what the fuck is he talking about? Alright. So we got our substitution. We're gonna do it. If we make that substitution, we're gonna have u plus u squared plus 7u plus 6 equals 0. So. Depending on how you go about solving it. If you use quadratic, if you factor. You're gonna end up with, I see that this factor, so I'm gonna do it. So we didn't start with you. We don't end with you. It's really square root of x. That might be easier for people to look at here. We could square both sides. That gets rid of square roots, right? I get x equals 36 or x equals 1. So let's check them. If I check u equals 6 or x equals 6, x equals 36. I have 36 plus 7 times the square root of 36 plus 6. Does that equal 0? without even doing it, is there anything in there with a negative sign? So there's nothing that lowers the value. So this is definitely greater than 0. So x equals 36 doesn't work. I think if you work that out, it looks like 42 and 42 is 84. If I try x equals 1, that's 14. Also greater than 0. X can't equal 1 either. There is actually no solution. Or you could say DNE, that's something people like to answer. Does not exist. Empty set is valid also. Any questions?
What would it have to do?
Nothing. There's no answer that works here. If we look back here, is there anything up here that actually generates a negative number? This could be negative,
Well,
but if that's negative, this is imaginary. So there's no mixing negative and imaginary. So there's nothing that's gonna actually equal 0.
but so does that mean that all equations like that are no solution?
I hate to say all equations, because like if I have a minus sign in there, shit changes.
Yeah,
If I have x minus 7 square root of 6, I think those both work.
does function the same.
Right, so it's like, when you say all of them like that, sure. All of them that look like x times 7 square root of x plus, or plus 7 square root of x plus 6 equals 0, none of those will work.
But if it was like A minus B.
If you got a minus in there, there's some way to go down in value.
Yeah.
So I'm not gonna eliminate anything, I would have to check every answer. We should check some numbers up in here, I'm gonna come back to this and check. We had x to the 4th minus 9x squared plus 20 equals 0. It doesn't matter if I plug in the positive version or the negative version. When I square it or raise it to the 4th power, they're all gonna end up positive. So I can check 2 solutions at once. I can check plus or minus square root of 5. So 5 or square root of 5 squared is 5. And then if we square that again, we get 25. So square root of 5 to the 4th power is 25. So this is 25 minus 9 times 5 plus 20. Does that equal 0? Yeah, we end up with 45 minus 45, which does equal 0. So both of those work. And it should be the same with the 2, but we'll double check it. To the 4th power is 16. 2 squared is 4 times 9 is 36. And that does equal 0. So all the solutions work there. You guys ready? Ready for more? Very good, please. The fuck? Now you're bringing in negative exponents, Jones. Don't be an asshat, Jones. Is this in quadratic form? Is one of the exponents double the other? Yeah, that's the one that's doubled. So we're gonna say u equals the smaller one. The undoubled. The u squared equals d to the negative 2. So we have u squared minus 7u plus 10 equals 0. This factors, but just for practice, since we covered quadratic formula today, I'll do it again real quick. A is 1, B is negative 7, C is 10. This is 49 minus 40 over 2. 49 minus 40 is 9. And square root of 9 is 3. So u equals 7 plus or minus 3 over 2. Here you actually have to split them up. Ten over 2 is 5, and 4 over 2 is 2.
Say factoring is the easiest way or the quickest way to find it.
If you can recognize the factors right away, yes. If you have to take too long finding factors, no. It's all about speed, efficiency.
The factors are just the two numbers that make up A times C.
A times C and add the B. All right, so this isn't about you. This is about D. What does a negative exponent mean?
The square root.
No. Fractional exponents have roots. Anybody?
It's like there's a fraction on the bottom, right?
It moves it to the bottom. It becomes 1 over d to the first power. The sign becomes positive, you move the variable to the
Is
bottom.
that like inverse or something?
Effectively, yeah, or reciprocal.
So you have to multiply them.
Yeah, you multiply by d. So we get d equals 1/5, or d equals 1/2. I just divided by 5 or 2.
Did we have to have d to the -2 or to the -1?
It was to the -1. When we check it. We're gonna check it. We gotta use that -2. So I've got 1/5 to the -2 minus 7, 1/5 to the -1 plus 10 equals 0. And you might think this looks really fucking hard, but you're wrong. If you remember what exponents the negative does, is it turns this over. This is the same thing as 5/1 squared minus 7 times 5/1 to the first power. That's the same thing. Because you're doing I can rewrite the 1/5 to the -1 as 1/1/5. And when you clean that up, that's 5/1. The negative exponents just mean flip it, do the reciprocal. So I've got 25 minus 7 times 5 is 35 plus 10. That does in fact equal 0. So d equals 1/5 works. We do d equals 1/2. Flip that over, it's a 2, and I square it, I get 4. 4 minus 7 times 2 plus 10. I get 14 minus 14, that also equals 0. They take a while, right? They're not short problems. But there's no particular step that's excessively difficult. Right? You guys ready? Shake your head, no, Teresa. You're ready. You can do this. What?
Did they go to sleep?
Rude.
Not because of your class.
I just heard I'm boring is what I heard. Wait, what? It gets better, you say?
But there's more.
But wait, there's more. Now I could multiply this all out and get an equation. I'm gonna have the x to the 4th in there. So it's already gonna be messy, but do I need to?
No,
Is this quadratic in form?
yes,
What's u?
x squared minus 3x,
That would make that u squared, right?
yes.
So it looked terrible. And it might turn terrible. Oh, wait, I did that earlier and I did not like the results of that. Poor Jimmy and or James and Sarah are too close. You're in the fucking splash radius. You may not like what happens. That does factor. Wait, what? Do I get to solve 3 quadratic equations in one problem? Are you fucking kidding me? This is like inception for quadratics. I have a quadratic in a quadratic. Inception's an old movie, that's a little while back. Does anybody even remember Inception? The dream within the dream, yeah,
Whatever messed up, you never know if you're awake.
right? But remember, this ain't about you. This gets less fun. We have to bring the 6 over and we have to bring the 4 over. This one's not too bad. This is x minus 4 and x plus 1 equals 0. So x equals 4 or x equals -1. This doesn't factor though, does it? So that means quadratic formula. Or complete the square, but I don't like completing the square with an odd number. So we clean that up, we get 3 plus or minus. That is 9 plus 24 over 2. This is some ugly ass shit. And ideally, you want to check each one. Not only because some of them might not work, but it also makes sure you didn't fuck up along the way. Right?
If they're, I can imagine it being kind of easy to say, oh, the one on the left doesn't factor. And you miss that solution, because
Right,
if you didn't know. Or you
right.
missed the section.
Because factoring only gives us things that we can find a factor for. Like, these are technically factors. I could have written x squared minus 3x minus 6 equals 0 as x minus 3 halves minus square root of 33 over 2 times x minus 3 halves plus square root of 33 over 2. Had I just had the brain power to figure out that those were the factors. But who's gonna ever come up with those? That does, yeah. Quadratic formula is your friend. Factor if you can do it quickly. If you can't figure it out within like a minute, just go over to quadratic formula, save yourself some time. Every once in a while, if the numbers are small, completing the square is, in my head, faster than the quadratic formula, but very rarely. All right, there's 2 other things that are in this types of equations that are in this section, but you've seen them before. So I'm only going to mention them here. Other things that generate radical or generate quadratic equations as in their steps. Radical equations can. and rational equations. I know we don't have that long, so I'm going through this at a normal pace here. We won't find the whole solution, but we'll get you started and show you how it ends up being quadratic. Here's a rational one. Do x minus 1. All right, what does Jones say? Fractions. But fractions, which means I need to multiply, the easiest way is just multiply by both denominators. I'm gonna multiply by x plus 4, and I'm gonna multiply by x minus 1. And this is technically, if you do this in other classes, your teacher might get mad. Like you're supposed to do parentheses on both sides and write it on both sides. But that seems like a lot of extra writing if you know what you're doing. This has to apply to that one and to that one. When it applies to the one on the left side, x plus 4 cancels. Right side, x minus 1 cancels with the denominators. And I'm left with the original 2x times the x minus 1 equals 3 times x plus 4. And you'll see when you distribute, you get an x squared in there. And that's where we'll stop solving that one. And the other option is the glorious, ever so glorious radical ones. We'll set up one of the more challenging ones, where there's 2 radicals. We did this before. You also, here you want to split the radicals. So I'm going to add one of them to the other side. I'm going to move the negative one over. Then we square it, right? But this right side is 1 plus square root of 3x plus 3 times 1 plus square root of 3x plus 3. So don't just jump the gun there. Left side simple. We have to distribute on the right side. And you end up getting some shit like this. So I'm going to move everything that's not with the radical over. If I square both sides here, this is 3x plus 4 times 3x plus 4 on the left. That looks like 9x squared. I get a 12x and another 12x is 24x. plus 16. On the right side, the 2 gets squared and the square root gets squared. So I get 4 times 3x plus 3. And now we can see we have an x squared, we got a quadratic equation again. So we didn't start with quadratics, but we ended with quadratic. Was that not super duper fun? Are you having fun, Sarah? All right, it's 5 o'clock, get the fuck out. Or hang out, I have an office hour till 6. If you want me to stay in here, I will stay in here, but that's it for lecture. As a reminder, I'm on the Mesa Center in Visalia campus.